So by applying the CPM and PER technique, we have to find the project management, the critical path method and total project duration and total and float for each activity. Among these two alternatives, you have to find the minimum value. So first I'll take 16 minus 4 is 12. So this is the first step you have to find. You have to find the earliest starting time, that is EI. Hello everyone, I'm Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my previous session, I have discussed about network analysis, and the main two techniques of network analysis is CPM and PERT. And also have discussed the concept called CPM and one example problem. So today I'll explain the problems on CPM. So CPM means this critical path method is a step-by-step procedure to reduce the total time and cost of each project. So by applying the CPM and PER technique, we have to find the project management. And now I'll explain one example problem in CPM. So CPM stands for critical path method. So your next problem is a project schedule as the following characteristics. So in the given question, they have given the activity and time in days. So 1 to 2, 1 to 3, 2 to 4, etc. up to 9 to 10. So this is your given table. So first step is you have to construct network diagram. So construction of network diagram I have discussed in my previous session, and you have to find the compute earliest event time and latest event time, and also you have to find the critical path method and total project duration and total and float for each activity. So let's understand the network diagram first. So 1 to 2 and 1 to 3. 1 to 2 and 1 to 3. So the duration is 4 and 1. 1 to 2 is 4, 1 to 3 is 1. Next one is 2 to 4 and 3 to 4. 2 to 4 and 3 to 4. For 2 to 4, 1 and 3 to 4 also 1. And the next one is 3 to 5, 3 to 5 and 4 to 9. 4 to 9. So 3 to 5 is 6, 4 to 5 is 4 to 9 is 5. And next one is 5 to 6 and 5 to 7. 5 to 6 and 5 to 7. So 5 to 6 is 4. 5 to 7 is 8. And next one is 6 to 8 and 7 to 8, 1 and 2. 6 to 8 is 1, 7 to 8 is 2. And next is 8 to 10 and 9 to 10, it is 5 and 7. 8 to 10, it is 5, and 9 to 10 is 7. So now have completed the network diagram. So first one have completed. Construct network diagram. First step is completed. And the next step is compute the earliest event time and latest event time. So here I draw the network diagram. Next is you have to find the earliest completion time, earliest starting time and latest completion time. That is earliest starting time and latest completion time for each and every node. Earliest starting time and latest completion time for each node. So for finding the earliest starting time, you have to use left to right, that is forward pass computation. In forward pass computation, you can find the earliest starting time, that is left to right, and for latest completion time you have to use the backward pass computation, that is from right to left. Keep in mind, earliest starting time, left to right, that is forward pass computation. And for finding the latest completion time, you have to use backward pass computation from right to left. So now I'll find out ES, earliest starting time. So for first node, earliest starting time should start from 0. And for second node is connected from 1 to 2. That means 0 plus 4 is 4. And 1 to 3, I have an activity called 1 to 3. So 0 plus 1 is, earliest starting time is 1. And for node 4, you have two possibilities, 2 to 4 and 3 to 4. For 2 to 4, you have two possibilities, that is 4 plus 1 is 5. And for 3 to 4, you have 1 plus 1 is 2. So 4 and 2, among these two values, maximum value is 4 plus 1 is 5. This is 5 and 2. 5 is a maximum value. So I'll take 4 plus 1 is 5 because we have to select the maximum value. So all the formulas I have discussed in my previous session, and 3 to 4 is 1 plus 1 is 2. So maximum value is 5. And for 3 to 5 is, you have 6 plus 1, that is earliest starting time is 7. And for 5 to 6, you have 7 plus 4, starting time is 11. And for 5 to 7, 8 plus 7 is 15. And for 7 to 8, 15 plus 2 is 17. So after this 8, find for node 9, that is 5 plus 5 is 10. For node 10, you have two possibilities, that is 9 to 10 and 8 to 10. So 10 plus 7 is 17 and 17 plus 5 is 22. So 22 is the maximum value. I'll write the earliest starting time is 22 for node 2. So we have to find the maximum value, and now for all the node have got the earliest starting time. Clear? So for each and every node you have to find the earliest starting time. That is the first step. And next is backward pass communication. And the next step is backward pass computation. You have to find the latest completion time for each and every node. By applying this earliest starting time, only you can find the latest completion time. So for the last node, for node 10, earliest starting time should be equal to latest completion time. So both the values should be equal. That is what I have written 22 in a node 10. And for the node 9, so 22 is the latest completion time, and 7, here we have 7. 22 minus 7 is 15. The latest completion time for node 9 is 15. And 10 to 8. So 22 is the latest completion time. 22 minus 5 is again 17. Clear? And for the next node, 8 and 7. The latest completion time for 8 is 17. 17 minus 2 is 15. And for the node 6, 8 to 6. So 17 minus 1, it is 16. Latest completion time is 17, minus 1 is 16. And for node 5, you have two possibilities from 7 to 5 and 6 to 5. You have to choose the maximum value for earliest starting time. And for finding the latest completion time, you have to find the minimum value. So here, among these two alternatives, you have to find the minimum value. So first I'll take 16 minus 4 is 12 and 15 minus 18, 7. So which is a minimum value? 7 is a minimum value. 15 minus 8 is 7. Is it clear? You have to find the minimum value for finding the latest completion time. And for node 5, you have one possibility, that is 9 to 4. That is 15 minus 5 is 10. And for node 3, you have two possibilities, that is 3 to 4 and 3 to 5. So first I'll take this 10 minus 1 is 9 and 7 minus 6 is 1. 1 and 9, the least value is 1. Clear? And for node 2, you have 4 to 2, that is 5 minus 1 is 4. And for node 1, 4 minus 4 is 0. The first node value is always 0. The initial value is 0 for earliest starting time, and for latest completion time, the initial value is 0. So now I have completed the earliest starting time, earliest event time and latest event time also have completed. And the next one is you have to find the CPM, critical path method, and total project duration. So dear students, CPM is very easiest concept. Please understand the logic. First you have to write the network diagram, earliest starting time and latest completion time for each and every node. And you have to find the CPM, that is critical path, and you have to find the time duration and float for each activity. That is your CPM concept. So next I'll find out CPM. For finding the CPM, you have to find out the table. So first is activity. List all the activities here. And the next step is I'll find out the CPM, that is critical path to this network diagram. So you have to write the table. So first column is activity. List all the given activity and time. So here the activity is 1 to 2 and 1 to 3, 2 to 4 and 3 to 4, 2 to 4 and 3 to 4 and 3 to 5 and 4 to 9, 5 to 6, 4 to 9, 5 to 6, 5 to 7 and 6 to 8, 5 to 7, 6 to 8 and 7 to 8, 8 to 10, 9 to 10, 7 to 8, 8 to 10, 9 to 10. List all the activity, given activity and time. So for 1 to 2, it is 4 days. For 1 to 3, 1 day. 2 to and 2 to 4 is 1, 3 to 4 also 1 and 3 to 5 is 6. 3 to 5 is 6, 4 to 9 is 5, 5 to 6 is 4, 5 to 7 is 8, 6 to 8 is 1 and 7 to 8 is 2 and 8 to 10 is 5, 9 to 10 is 7. First, you have to write these two columns, that is given table, activity and time. So next is you have to find earliest and latest. Earliest time and latest time. For earliest time, I can call it as ES and LS. Latest is LS. And for earliest, I'll find the starting time, that is EI, and for finish time, again start and finish, and next is total float. Clear? I'll find out the total float, and this time is for TIJ, time for starting and ending, EI, and this is ES, and here I have to find LJ and total float. So how to find this starting time for each and every node? Now I have to find the earliest time for each and every node. For 1 to 2, listen carefully, for 1 to 2, earliest time is 0. And for 1 to 3, earliest time is 0, latest completion time is 1. And for 2 to 4, earliest time is 4 and latest completion time is 10. Clear? So this is ES and this is LC, latest completion time. So now I'll find out for 1 to 2. For 1 to 2, earliest time is 0. 1 to 3, earliest time is 0. 2 to 4, earliest time is 4. And 3 to 4, earliest time is 1. And 3 to 5, earliest time is 1. And 4 to 9, earliest time is 5. 5 to 6, earliest time is 7. And 5 to 7, earliest time is 7. 6 to 8, earliest is 11. And 7 to 8, earliest is 15. And 8 to 10, earliest is 17. And 9 to 10, earliest is 10. Clear? So this is the first step you have to find. You have to find the earliest starting time, that is EI. So what is next? So you have to find the starting finishing time, that is you have to add this EI plus TIJ, you will get the earliest finishing time. That is 4 plus 0 is 4, 1, 5, 2, 7, 10, 11, 15, 12, 17, 22 and 17. Clear? This is your earliest finishing time. And now we have to find out the latest starting time. So how to find this latest starting time? Listen carefully. For first node 1 to 2, latest completion time is 9 and the duration is 4. So 9 minus 4 is 5. And for 1 to 3, latest completion time is 1 and the duration is 1, it is 0. And for 2 to 4, completion time is 10, duration is 1, 10 minus 1 is 9. And 3 to 4, completion time is 10, duration is 1, it is 9. And 3 to 5, completion is 7, duration is 6. 7 minus 1 is 6. And 3 to 5 is completed and 4 to 9. 4 to 9, completion time is 15, minus 5 is 10. And for 5 to 6, completion time is 16, minus 4 is 12. And 5 to 7, completion time is 15, minus 8 is 17. And 6 to 8, completion time is 17, minus 1 is 16. And 7 to 8, completion time is 17, minus 2 is 15. And 8 to 10 is 22, minus 5 is 17. And 9 to 10, 22 minus 7 is 15. So next step is you have to find the latest finish time. For this you can add this column and this column. 5 plus 4 is 9. 1 plus 0 is 1. 9 plus 1 is 10. 9 plus 1, 10. 6 plus 1 is 7. 5 plus 10 is 15. 12 plus 4 is 16. 17 plus 8 is 25. 16 plus 1 is 17. 15 plus 2 is 17. 17 plus 5 is 22. And 15 plus 7 is 22. So if you are subtracting with start, so you will get 0 minus 5 minus 0 also 5, and 9 minus 4 also you will get 5, and 1 minus 1 also you will get 0, and 0 minus 0 also it is 0, and 10 minus 5 is 5, and 9 minus 4 also 5, and 10 minus 2 is 8, 7 minus 7 is 0. And 15 minus 15 is 0. 17 minus 12 is 5. 17 minus 17 is 0. 22 minus 22 is 0. 22 minus 17 is 5. So now I got the float also. So wherever you got the 0, you just mark these zeros here. So you just mark all the zeros, that is called as critical path. So this 0 comes under 1 to 3 and this 0 from 3 to 5 and this 0 from 5 to 7 and this 0 from 7 to 8 and this 0 from 8 to 10. So this is called as critical path. So here wherever you got the 0, that is your critical path. Now mark it in your network diagram. So 1 to 3, wherever I have put the double arrow, that is your critical path, 1 to 3. And next is 3 to 5. 3 to 5 is your critical path now, 3 to 5. And next one is, it is 5 to 7. So 5 to 7 is critical path. 7 to 8 is critical path and obviously it is 8 to 10 is your critical path. So 8 to 10 is a critical path. So now you can see the diagram. 1 to 3, 3 to 5, 5 to 7, 7 to 8 and 8 to 5. This called as critical path. So first you write the critical path here. 1 to 3, 3 to 5, 7, 5 to 7, 7 to 8 and 8 to 10 is called as critical path. So this also have completed critical path. And total project duration. You just add all the time duration for 1 to 3, 3 to 5, 5 to 7, 7 to 8 and 8 to 10. So 1 to 3 duration is 1 and 3 to 5 duration is 6 and 5 to 7 duration is 8 plus 7 to 8 duration is 2 plus 8 to 10 duration is 5. Add these two values. So 6 plus 1 is 7, 7 plus 8 is 15, 17 and 22. So 22 is your total duration for this critical path. And also I found this float for each activity. So this is a float for each activity. So this is about your CPM problem. So first you have to draw a network diagram with arrow and you have to find the earliest starting time and latest completion time. For finding the earliest starting time, you have to use the forward pass computation from left to right. And for finding the latest completion time, that is LC, you have to use backward pass computation from right to left. So once you got the earliest starting time and latest completion time, you have to find the earliest starting time and earliest finishing time and latest starting time and latest finishing time, and you have to find the total float. So once you got the total float, easily you can find the CPM, critical path method. Wherever you got the 0, you just mark the 0. From this 0, you will get the critical path 1 to 3, 3 to 5, 5 to 7, 7 to 8 and 8 to 10. So this is called as critical path method. So after this, you just mark the critical path here and find the duration for this critical path. So this is about your CPM problem. It is very important concept. Please practice this. Understand the logic. Easily you can score in CPM problem also. In my next session, I will come with a new concept called PERT. Thank you.